Today I will show you how to mesh a heat chamber. A heat chamber heats up the air flowing through an inlet, which goes through a chamber and is heated up by heated walls, then flows through the outlet. This is pointing upwards, as the air gets heated, the hot air rises out through, so you don't have to add any energy to make it move through. These are the dimensions of the heat chamber, and the inlet and outlet are split up as such. This is done so the inlet is split here, in the middle and here, which corresponds to these edges here. This makes it easier to mesh and defeature the mesh, as the outlet is also split here, here, in the center, here and here. We then open ANSYS Fluid Flow and go into Design Modeler, and then create the sketch as shown previously. These are all the dimensions. It's quite simple to make, as you just draw a line, dimension it, keep going until the sketch is completed. Once the sketch is completed, make a surface from the sketch with 0 millimeters, and that just creates a surface. Next, we want to split the inlet and outlet as such, so we will use split edges for that. And for the bottom, we will split it up using 3 locations. We'll do it by coordinates. So the first one is 17, and 25, and then 33. And as you can see, this lines up the locations with the middle and these, which creates these square boxes. We will then repeat this for the outlet, and it will be done by 5 locations, and then again by coordinates. First one's 5, and then 17, and 25, $33, and 45. As you can see, this now splits up perfectly as well, as these all aligned with the center, and then these ones aligning here. Then click Generate, and then our surface is ready for meshing. We will now open the meshing phase, and then go on Mesh, go on Sizing, make sure Use Adaptive Sizings yes, and Mesh Defeaturing is also yes. Then we will now update to create the basic mesh. And the mesh translation to fluent was successful. Now apply mesh facing to our heat chamber. Which has already created a more structured mesh. We'll now insert edge sizing to defeature the mesh and get the perfect mesh we want. First, we will do the 4 middle edges, then use number of divisions, go 15. We will use a hard behavior on all of these, which means the mesh will connect together in all the sizing we do. We'll have a biased where it goes small to long, which means the mesh is more condensed here and the space is out towards the middle. Smooth transition, a growth rate of 1.1, and then update. As you can see, it's dense and then smooths out, but we want it dense and then to smooth out in the middle on both, which means the left top and bottom right will need to be reversed. Like so. We'll update. And now the mesh should be dense on the outside and smooth on the inside. We will now repeat this process for all of the edges. Next, we will do these 4. "25 divisions. Hard behavior again. We will have a thick to thin bit biased. Smooth transition 1.1 as well. And we'll take a look. As you can see, this is the wrong way around again. So we'll need to split it and reverse it again. So these are the wrong way around. And generate. Now, as you can see, yeah, the mesh is now correct, but being more dense here. Then move on to these 2. And 30 divisions. Now we will do the more dense, the less dense, the more dense. Smooth transition, as always. And a 1.1 growth rate. And now, actually sorry, that's meant to be 70. And now we will do the same to these two edges. "30 divisions, hard, dense, less dense, dense, biased, smooth transition, and a growth rate of 1.1 as well." So we've now done the bottom half of the chamber. So number of divisions, we will do these ones, plus their corresponding edges here. Uh, 30 divisions. As always, hard behavior, and then we'll have an dense, less dense, dense behavior, smooth transition, 1.1. And then again, these two edges. "50. Hard behavior, and the bias will be dense, less dense, dense, smooth transition, 1.1. And then we will do these four. "20 divisions, hard behavior, and we will have less dense to dense, bias, smooth transition, 1.1. So we need to reverse these two. Yeah, that's perfect. And then we'll do one more. And then number of divisions will be 70. And always hard, dense, less dense, dense, biased, smooth transition, a bias factor of 1.1. And then we'll generate the mesh. Now, as you can see, we've now highly defeatured the mesh, and this is the exact mesh we want. So when the air flows through here and out of here, we need the mesh to capture what happens here at the edges, because this is where the main change in flow happens, so it's more dense around the edges here. Also, as you can see, the more dense locations go to less dense locations to more dense, and there's never an abrupt change in mesh. So everywhere where there's a more dense location, there aren't any less dense locations. It's all dense locations, and it smoothly goes to less dense, to more dense, to less dense. And that's how you get your exact mesh you want.